Welcome to the live stream. Looking at the sun on 193 angstroms. We see a coronal hole incoming. Sunspot 2736. Still some level of a threat for solar flares and for coronal mass ejections, actually. And we see really two coronal holes. One just near Earth-facing zone and one quite far south. Let's look at some other views, but first let me pull out my draw on screen device. There we go. And let's take our time going through this, as we do want to give some time for folks to be able to join the live stream. We'll look at 304 angstroms also. Solar activity extremely low. It's dropped down below 80 on the 10.7 centimeter radial flux. We're now down to 79 last I checked. And there are some plasma filaments there on the southeast. Now for those irregular viewers, we refer to this side of the sun as the east and this side as the west. Yes, I know when you look at a map it's opposite, but this is the side where the space weather rises and this is where the space weather sets. We name most of this stuff based on a heliocentric view of the solar system. And that's why it's east and west. And that's why stereo A is on this side and stereo B is on this side, because this is ahead and this is behind. Get it? All right. Let's look at the colored magnetogram. Get the last look that we'll get on this show of Sunspot 2736. And it has not decayed very much at all. There's a view of that. The magnetic complexity on the leading portion of Sunspot 2736 is still crackling with energy. And let's look at some other information here, starting with the real-time solar wind. Now, we never got the coronal mass ejection that we were predicting yesterday, and everybody was wrong. NOAA was wrong, NASA was wrong, SolarHam was wrong, SpaceWeatherNews.com was wrong, SpaceWeather.com was wrong, and smAsho was also incorrect. So we're going to do some further analysis here in a moment. Here's the real-time solar wind. Let me see if I can shrink this thing or scroll or do anything with it. Okay, this is the weakest solar wind that we've ever reported on our channel. I'm going to shrink it down to 6 hours. So you can see the solar wind speed is all the way down to below 300 there. We're looking at about 270 kilometers per second. Solar wind density at about 7 protons per cubic centimeter, I think. And I don't know why this looks so terrible lately. This is not cooperative at all. Let's see if I can load the 1 day again. This is supposed to be an interactive view, and I'm sure it has to do with the fact that we're doing this on a smartphone right now. Now we do see a coronal hole magnetic connection going on there, so that increases your earthquake risk. Again, solar wind extremely low, and I can't really click on it, but it's below 300 kilometers per second. That's the lowest we've ever reported. since we've been doing our daily videos. Now let's look at the magnetosphere movies, as we should see extremely weak magnetosphere. Here's the velocity. Let me get these other ones to load first. We're getting a high density around the planet due to the extremely weak solar wind. Which causes high density. I know it seems counterintuitive, but that's the way it works because the magnetosphere holds off the solar plasma from directly hitting the Earth. So here's the velocity, extremely low. Here's the density. It's actually a little on the high side around the planet, and that's because of the weak magnetosphere. Not a lot of current flowing right now. And we've had a long period of time with KP 0, KP index at 0. So there's the pressure, the density, and here's the pressure, and I believe this is the weakest we've reported also. If anybody has seen a weaker weaker magnetosphere pressure than this, let us know. We haven't covered it at a lower level than this, I don't believe. And thanks for joining us, part-time friend. Appreciate you joining us. So you're in Korea, huh? Nice. What brought you to Korea, or are you from there? Next we'll look at the gong 2. Gotta look at the gong 2. Get it on, bang the gong, get it on. And it decided to load an offline page. I don't know why. I certainly didn't tell it to. By the way, we use Brave Browser, a browser designed not to track you. All right, if anybody can let us know how many folks are in the chat, we'd appreciate it. So there's the gong 2. We do see a magnetically complex region showing up here, just ahead of us, right in that area. You see those long straight lines that go all the way to the corona. Those could induce a magnetometer spike in the coming day. But besides that, not a lot going on at all. All right, so let me head to the next tab here, spaceweathernews.com. Look at a little more data. Let me close that thing. Whoops. No, that thing. There we go. All right, so here we are, spaceweathernews.com. Props to Ben Davidson. Are we on desktop site? We are not. This view's better on Brave Browser Mobile Edition, viewed as a desktop site. So we see the X-ray flaring has started to subside a little bit, although lots of B flares coming off, and no C-class flares since... Oh, actually, that one actually was a C-class there. It just broke the line. But as Sunspot 2736 sets, there is still some threat of coronal mass ejections, and we'll explain a little bit about that in a moment. There's that extremely low solar wind we're talking about. Magnetometer's looking smooth. KP index has been at 0, increasing the risk for human health, cosmic rays. Human health risk from cosmic rays. Quite high right now. And we're approaching 24 hours with a KP 0. So that's very surprising, as we were expecting to get a KP 6 event yesterday. We thought this was going to be all the way up here. We thought we were going to see that. And pretty much everybody around the planet was predicting the same thing. We were looking at, right around this area, KPS6, for about 2 to 3 hours, but it just never showed up. So the theory from me is that it missed to the west, and I'll show you why momentarily. There's the electron flux looking very smooth. No proton events, no charging hazards. The F2 layer is looking a little less charged than it has been in the recent weeks, but nothing too extravagant to comment on there. SpaceWeather.com has got some interesting information on it today. I urge you to check it out. You got a great photo of sunspot 2736 as it sets. And these things can still send a coronal mass ejection toward the Earth. Now, when they're totally opposite the Earth, 180 degrees around the other side of the sun, then it's nearly impossible at that point. But when a sunspot is setting, it's still capable of sending a coronal mass ejection our way. And here's a little diagram, interesting article. Keep in mind the solar wind comes out in a spiral, and our regular viewers are probably aware of that, but the way magnetic lines connect and disconnect, the plasma can be sort of slingshotted like a spring around the sun. And that's kind of the way it works. So interesting diagram there. And if you like, you click on that, it'll take you to an article. And it's got some interesting animations and other information about the way the Parker spiral works. By the way, the Parker Solar Probe is named after the gentleman that came up with this science. So I urge you to read it. Just head to spaceweather.com and click on that diagram. Some interesting material there. Now, the 10.7 centimeter radio flux has now dropped down to 79. So this is going to be updated today. I would note that it is still well above forecasts at 79. Next, we'll look at solarham.net, because solarham.net is nice enough to put the LASCO C2 and C3 right on their homepage. So to make it as easy as possible for our viewers to get this information for themselves and learn the science, solarham.net. So I wanted to look at the LASCO C2 and C3 here, because these images start out with the coronal mass ejection on the 20th. The first frames are the coronal mass ejection. Let me just let that play through again. And you will see most of the ejecta ends up on this side. There is a bit of a halo when it first goes off. You'll see it on both sides. But most of it was to the west. And that's the way the models look, such as the Enlil spiral. You can also see this on the C2. Excuse me. The dangers of a live stream. I'll let that play through again. You see that there is an additional coronal mass ejection also, which also misses way to the west. And we looked at that only a couple hours after it happened. On the 20th, if you'd like to view the analysis, just check our older videos. All right, so that's the working theory, is that the entire coronal mass ejection, almost the whole thing. I think there was a tiny spike yesterday or two, but there was no significant uptick in the solar wind density. We were expecting 20 to 30 protons per cubic centimeter. We ended up with about 7. And on that note, we'll look at the Space Weather Enthusiast dashboard, because here's what we're talking about. Now, this is NASA's prediction. NOAA's prediction was slightly different. Keep in mind, NASA and NOAA both have a lot of reason to predict this stuff correctly. as NASA has astronauts and satellites, and NOAA has things like the weather, the power grid. It's kind of important. So you see that spike that was predicted on the 23rd. We were all predicting that. It just never came. So here's that Parker spiral we were talking about. And let's look at the X-ray, the GOES X-ray imager here. As we did see kind of a constant crackling of X-rays. So give you a quick view of that. Sunspot 2736. Within the next 36 hours, we should not see any more X-rays from that. And I don't think that's going to show us very much on the visible light viewer, so let's move on to the earthquake map. Now, we did see a 6+ magnitude earthquake in, I believe it was Colombia, unfortunately at depth, which means the risk for future earthquakes is still there. And now we're looking at this extremely weak solar activity again, coronal hole with a possible magnetic connection going on right now. So let me just draw in the watch zones, as they have not expired. We're in a massive drought of magnitude 6 and 7 earthquakes. So if you're in these areas, please have an earthquake plan, as earthquake droughts tend to always end, right? So if you're in those areas, please be a risk, not a liability in the event of an emergency. Having some idea that another earthquake may happen is better preparation than nothing at all. Step outside the building that you'll evacuate if it starts to shake, and look up. Is there a 20-ton gargoyle statue that might be falling on your head as you walk out the door? Being aware of that could save your life, so those are the watch zones. The drought continues. Let's look at the list. We're only going to cover 4s+. And that's 4+ magnitude earthquakes. And we are in a massive earthquake lull. Look at that. So 5 hours ago, we see a 5.4 in Indonesia, right at the surface. Carlsberg Ridge sees a 4.8 and a 5.2. And those are two separate quakes. They're about a minute apart. Let's take a look at that location. I can't say for sure I remember where that is. Okay, there you go, in the Indian Ocean. And, okay, we see a 6.1 in Indonesia. I thought there was a 6 on South America. That must have been older. So that's the largest quake in the past 12 hours, at least. Indonesia, right smack dab in the middle of our watch zone. Very earthquake and volcano prone area there. The Kuriil Islands with a 4.7. A little north of Japan. South of the Kamchatka Peninsula, where there's a lot of volcanic activity going on. And also a 4.6 at depth at Chile. Okay, that's what I was looking at. 4.6 at depth at Chile. Now, for those of you not aware of earthquake prediction techniques, there is a technique to predict earthquakes. 1, you wait to see a deep earthquake. Let's take this for an example. There's your deep earthquake. It's over 100 kilometers deep, and that is the harbinger of a larger quake at the surface. Coronal hole magnetic connections are associated with this, which is why we look at the phi angle of the solar wind. When it rides around 180 degrees, that increases earthquake risk. And then lastly, we want to look for anomalous low pressure systems doing weird things on the plate boundary. So if you see a low pressure system, for instance, in this area, and it's moving west instead of east, that's an anomaly. That's a risk factor for an earthquake. So I know it can get complicated. You got to know meteorology and solar science and seismology all at the same time, but hey, that's science for you. Let's look at the volcanoes of today. Bro, Bromo is totally erupting, like right now, like for real. I mean, that 10,000 foot ash plume that's producing is totally not something to fly over on a skateboard or on any kind of like Evel Knievel style motorcycle jump. That would be super irresponsible. Also, Dacono producing a 5,000 foot plume. Sabancaya with a 27,000 foot plume down in Peru. Planchon Petro with a 15,000 foot plume. And Nevados de Chilean producing an isolated puff. Let's click on it. Well, that wasn't so exciting. I thought you were going to give me a photo. All right. By the way, here's the Gong site. There's a lot of data on here, including synoptic maps and all kinds of interesting stuff. If you want to check that out, have fun. I'm not doing it. Now let's look at some cosmic ray sites. See if we had any uptick because of this ongoing KP0 situation. Failing to block out galactic radiation. Yep, there you go. There's an uptick in cosmic rays. Just in the past day at Apatity. Here's Barentsburg. Also seeing an uptick there over the past 4 or 5 days. We've had very low KP indexes for the past 4 or 5 days, so corroborating the magnetosphere versus cosmic rays. Here we see an uptick at Athens also. Here's Mexico City, following suit with an uptick as well. We used to cover Moscow. Moscow has not returned data since February 22nd. Here's Oulu, Finland, an uptick there also. DOMC Antarctica, DOMB Antarctica. Those don't really agree, but all of the non-polar neutron monitors are showing an uptick in cosmic rays, folks. So be aware of it. Let people know. Treat health concerns seriously. We don't want a KP0. Here's an article on Wikipedia. Health threat from cosmic rays. This is a well-known thing. And let me just show you this graph. Now, keep in mind, most cosmic rays, like the solar wind, are made of protons. And they get split into field-aligned currents, just like the solar wind does. The sun and the heliosphere block most of those from making it to the planet. When you have a low KP index, like a KP of 0, magnetosphere is weak, and cosmic rays are able to get deeper into the Earth's atmosphere. This causes cloud nucleation, increases the Earth's albedo, and cools the planet. It's a feature of a solar minimum. Now, you can see here it's corroborating what I said. Galactic cosmic rays consist of high-energy protons, 85%, helium, and they mean helium nuclei, by the way, 14%, otherwise known as alpha particles, and other high-energy nuclei. And what they mean by that is all of the elements. All right, let's move on here. I wanted to show you a graph. There are the human health effects. So, sea-level cosmic radiation, you're getting less than 1, what is that unit there? I can't read that. Millo whatever. You get nearly 10 with an abdominal CT scan, and you get hundreds and hundreds on a trip to and from Mars, which is why going to Mars is a silly idea, especially at a time of a solar minimum. Who wants to spend 6 months going to Mars and not even make it back alive? You want to radiation sickness to death? Go to Mars. It sounds like a really fun thing. Let's go back to talking about the sun. Here's an abstract, and I recommend you find this article and read it. The Sun on Trial by Pierre-Marie Robitaille, published in March of 2014. For 150 years, the sun has been seen as a gaseous object devoid of a surface as required by the standard solar model, yet not one line of observational evidence supports a gaseous sun. In contrast, overwhelming evidence exists that the sun is comprised of condensed matter. Recently, 40 proofs have been compiled in conjunction with the liquid metallic hydrogen solar model. This model advances that the sun is a true surface. Photospheric structures, such as sunspots, granule, and faculae, are not illusions, but real objects with a condensed nature. Electron affinity, not temperature, governs the ion profile. The chromosphere is a site of hydrogen and proton capture. Line emission in this region strongly supports the idea that exothermic condensation reactions are occurring in the chromosphere. Well, let that sink in, folks. All of you who've taken an astronomy class, if you think we're BSing when we tell you that physics is getting rewritten, we're not kidding. We just hope it doesn't cause major destruction. Here's Dr. Robitaille at Electric Universe 2014 talking about the paper I just referred. Well, let's just skip into the middle and let him say whatever he's going to say. I'll full screen it. Now, we have no context here, but I'm just going to give you a clip as a teaser because you should go watch this 41-minute video. Learn the true nature of the sun.
New York Times article cited for you guys. Now, remember, I was trained as an inorganic chemist, and you learn in chemistry that hydrogen is the little cousin of carbon. So isn't that convenient? Now, right at the time that Jeans was losing his building block in the 1920s and had to abandon his liquid sun, if he had read Wigner and Huntington's paper, he would have had the solution. Because Wigner, who's a Nobel Prize winner in physics, said that at high temperatures and pressures, hydrogen will become metallic. It'll assume a structure which will be condensed. So let's read exactly what he said. The objection comes up naturally that we have calculated
I think we can let
the
this
energy
play.
of a body-centered metallic lattice structure only, and that another metallic lattice...
A metallic lattice structure. Coronal holes are outgassing of intercalate layers in between that metallic lattice structure, and Robitaille has the best theory I've seen to explain solar activity. Please continue.
...may be much more stable. We feel that the objection is justified. It is possible, however, that a lattice-like lattice has a much greater heat of formation and is obtainable under high pressure. Diamond is a valence lattice, but graphite is a layered lattice. So here what happens is Wigner...
In any case, the inside of a sunspot looks a lot like graphite, which is a lot like soot. And we're talking black body radiation here, folks. Now, this presentation, he's doing this to a whole bunch of different types of scientists. We're talking about astronomers, physicists at the Electric Universe 2014. So please watch the video. It's on Thunderbolt's Project, which is one of our officially endorsed channels. So you can just search for that or whatever. You'll be able to find it. You're not going to see links in the description today. And I don't know why we're back on spaceweathernews.com. I meant to go to someplace else. And that's the veloshop.net. The best bicycle shop I've ever seen. And I've been doing this for a while. So it's closed today and tomorrow. But on Tuesday, head out. People drive from miles around, from hours away. And if it's bike related, they've got it. Also, they have the best bike mechanic I'm aware of, Alan Schaefer. And let's go back to one more thing. The American Institute for Behavioral Research and Technology. Why do I care? Here's why. Because of the creepy line. If you type in mygoogleresearch.com, you will get referred to this site. Now, this guy's writing scientific papers about the behavioral impact of the surveillance state, shadow bans, and the creepy line that Google has crossed. The creepy line. If you're not familiar, head to duckduckgo.com and type in the creepy line. You'll see about 10 trillion articles about it. So let's take a look at 171 angstroms, go through the chat. If anybody's actually here, I know we're doing it early today. The thing is, we got to do it early on Sundays. It's just the way it goes. So there's our setting sunspot 2736. And what are we talking about here? Scientific? Yes, the intellectual dark web. Scientific. All right, we are out of here. Thanks for tuning in, everybody. We are considering another video today. We thought about actually producing this video, but we just did it live. It's a little more interactive, and it doesn't require very much file manipulation. So thanks again. Please don't forget to like and subscribe if you enjoy the content. Please share on your social media, as we are as shadow banned as you could possibly get. Thanks for joining us, Chrissy Williams. It'll never be now again. So remember, when you're bidding Sunspot 2736 farewell, don't drink it. If you drink, bid the Sunspot farewell. Just don't drive.